Hello everyone. Actually, this technology or start company just spun off from Taiwan National Laboratories. And I didn't know you guys know about organ on chip or human on chip. Actually, this is a technology. We are not right now organ on chip start company. They are competitors. Actually, we are solution provider. Okay, so our slogan is very simple, and we do the design for manufacturing for organ on chip or human on chip. Okay, and later on I won't use organ on chip this name because for Taiwanese, the day one we provide a total solution. So we define as our technology is human on chip, not just organ on chip. Okay, so just give you a quick idea why Taiwan National Laboratory, we decide to pay attention on these territories and give you a quick idea that every year around the world, over 100 million mammals was killed by human beings. For what? They do the medicines, they do the clinical trial, they do the everything, try to help human beings. But is this kinds of methodology is good enough for our efficiency? Totally wrong. Okay, just give you an idea. If right now we try to make the successful medicines for human being, for patients, you know what? We told double means that you spend more than 10 years and the $1 billion budget, you just get one kind of medicines, and the successful rate actually less than 2%. So we kill so many animals, but we use a so inefficient way to get the medicine and the solution. Did you start? It makes sense? Give you an idea. Right now, everybody knows Taiwan. We have very strong semiconductor manufacturing capability, right? Give you an idea. COVID-19, the virus, how big? The size? Around 100 nanometer. But TSMC, they can do 2 or 3 nanometers, those kinds of transistors. So right now, human being, we have so strong, accurate manufacturing process. Why now we can provide a solution? The solution accurate to mimic yourselves. So in the future, it's you. When we talk about human on chip, it means your category, your DNA, your signal, actually narrowed down to a one chip. So it will be very accurate. So we just do the mimic by yourself to make sure those kinds of medicines or those kinds of persons actually will infect you or impact you, positive or negative. That will be more efficient. So actually the United States EPA organization, they have a guideline say, hey, by 2035, we have to terminate the animal testing. So right now, everybody, we are looking for the alternative solution, right? But why Taiwan National Laboratories, we didn't define ourselves just organ on chip? Because once you Google organ on chip right now, you will find so many startup companies, they do the organ on chip already. But unfortunately, you know what? It's a little bit no sense. Because you know, the bio guy, when they try to jump into these territories, the idea is diversify. For example, some company, they have done those kinds of on-chip. And if you are a new company, you will do what? You will try to use liver to differentiate. Or even both of the team or both of the researchers, you do the lung, they try to differentiate. But doesn't make sense, right? We are a human being. So theoretically, your lung is very similar as myself. But if a bio guy, they do the organ on chip, they try to differentiate. Otherwise, they come to issue the paper or issue the patent, right? So Taiwan, we have very strong semiconductor capability. Our idea is it possible that we provide a reference design, and the reference design we provide to our global customers and the partners, and you just based on our reference design to do the differentiation. In this case, theoretically, we can leverage Taiwan economic of scale capability to cost down to meet the target price 35 per chip. Right now, actually, the price 100 times. Actually, 100 times, because you run a differentiation, right? Your organ on chip is different as yours. So every time you get an order to factory, the volume is very small, so very expensive. So if Taiwanese, we can combine together the whole demanding into the one reference designs, that means we can leverage economy of scale. So that's our strategy. We try to meet the magic number, $35 per chip. Why is 35? Because right now a mouse, animal mouse, the hospital, doctor, they use the mouse to do the animal test, is 35. So your solution, your alternative solution, you have to less than right now solution. Otherwise, it's impossible. We done the mission, right? So that's our strategy. So simply speaking, that currently we have provided the reference design combined electricity signal as a mandatory. Why we have to do that? Because human being, if you used to go to hospital, did you find any medicine instruments? Always they double check it's your electronic signal. That is mandatory and necessary if you want to do the treatment, right? So our solution, the day one, we combine the sensor, they got an electronic signal to combine with other message you got. So it's a reference design. And actually, right now in Taiwan, many research team and the star company spun off from university, right now they are our customers. We use our reference design to help them to speed up their process. But at the same time, they still do differentiation, but based on affordable price. So that's our price. That's our strategy. So that is our target because we still start company. I have to tell you some business or market number, right? So that's our target. By next year, we will have more than 5 customers from organ on chip star company or medicine company. And in 2 years, our total shipment based on reference design will more than 100,000. So, okay, let's work together to make the animal happily, peacefully live with us around the world. Now, thank you so much. Thank you.
Thank you, Simon. I would say, take a seat. Anyone you like, Simon. As a man who last week a doctor said to me, "We've just seen your ECG. It's not quite as it should be, but we've Googled it and we think it's normal for you." So I feel this is a piece of technology I can use. Does anybody have a question? I have a microphone. If not, I'm going to leap in with my first question to you, Simon, which is, how does this technology differ from your competitors?
Okay, theoretically, right now we didn't have competitor. actually the so-called potential competitor, at the same time also our customer, potential customer. For example, I just call the name. For example, right now, organ-on-chip around the world, the #1 stock company called Emulate. By Emulate, first of all, of course, I just mentioned about the different organs. They use different solutions. Of course, most of the solution was customized, so very expensive, and at the same time, the signal can cover to each other. For example, COVID-19.
Yeah.
When we use the vaccine for COVID-19, you know, the side effect usually come from your heart because electronic signal. So if I provide an organ-on-chip for lung, but without the interactions with your heart, it doesn't make sense, right?
Sure.
Yeah. So we try to sell our reference design, not sell. Stage 1 is approach. We try to approach potential competitor to let them know we are not your competitor. We are your solution provider. Currently, you are our competitor in star company, this area. But actually, in the future, you are our customer. You are our honored customers. So actually, Taiwan National Laboratory right now, our solution is the global only one. For my understanding,
sure.
For my humble opinion, the only one we combine electronic signal at the day one and can do the design for manufacturing.
Okay, lovely. Anybody else have a question for Simon? This is your last opportunity. Otherwise, you can catch up with Simon. You're around all day. You can catch up with him elsewhere. Anyone else? Okay. Top in his class is Simon Chow, everybody. Simon, thank you very much indeed.
Thank you.
Good afternoon, everyone. As I want to say, the P-Waver is a spin-off company from Anchor. So on behalf of the CEO, Dr. Pei-Yang Lin, I will give some briefing about the P-Waver. And I'm the Deputy Director General of Anchor. Okay. So the P-Waver is a smart disaster and prevention system company. We can see that we have too many disasters after the earthquakes. So if we want to protect people, protect the buildings, protect the equipment, we have to some warning system, and then we can do something before the strong shaking. So the P-Waver have the two total solutions. First one is before the strong shaking, and then before shaking, we can take the small amplitude of the ground shaking, and then we calculate the following intensity of the strong shaking. If the intensity exceeds the threshold, and we'll give some alarm. And each alarm not only to see, to hear, we can pass the automatically control system, and then we can do many things that the human cannot do in the 2 or 3 seconds. And then after the strong shaking, people want to know, oh, my building is still safe or not. So the P-Waver is also install some health monitoring system, and I put sensor on your building for the many stories. And then after the earthquake, we can measure or we can detect the vibration on your building, and we can do some calculation, and based on some index, we can know the building is still safe or not. If it's still safe, you can live here, no problem. And if we have some damage, and we can follow the smart evacuation guide to lift the damaged building. Okay, just in Taiwan, we have the 2 types of the early warning system. First one is developed by the CWB, Central Weather Bureau. Because based on the seismic networks, we can detect the earthquake happened anywhere, And if the 3 of the observation stations detect the signal, we can calculate the epicenter and the magnitude of the earthquake. And then based on the attenuation law, we can know the intensity at everywhere. So it's called a regional early warning system. However, P-Waiver developed the on-site. That means that I need only one sensor in my building or the neighbor building. And then we can detect the faster P wave. And then we can calculate the amplitude of the P wave. We can take the 3-second data. And based on the AI calculation, we can know the intensity of the following shear wave. So if the predicted result is the threshold, we can give some alarm. So we can know that near the epicenter, because we say that the 3 observations will detect the signal and to calculate the seismic source. However, for our system, we have only one sensor. So for the near source locations, we can detect the period first, and we can get alarm earlier. So we can see that just mentioned here. Okay. Please click for us. Okay. Yeah, first click for me. Yes, thank you. Okay, yeah. So you can see as the time going, when detect the P wave, yellow line is the 3 seconds. We can take the data to calculate the predict PGA, and the ground is shaking still and strong. So we can find that after the earthquake, the major PGA is about 23 gales, and we have the 5.4 seconds for the alarm time. Okay, in fact, the system is operated just like the slide shows. Based on the AI-EW development, we can put some sensor on the ground. And because there are many data we can observe from the earthquake experience, so we can train in the machine based on the neural network. We can take some feature of the P wave and then calculate the following PGA. So we train in the machine, and as the machine detects the signal, we can know the following PGA. So we can just show here, after the earthquake happened, P wave arrived, we can take 3 seconds, and AI calculate within the only 0.01 second. And then we can give the alarm. So from the alarm to the maximum intensity, we can obtain 5 to 20 seconds. Okay. And so it just shows the comparison of the on-site set and the regional system. From the earthquake up here, the last year, we can know the first station we observe, we can give the alarm. And after 3 stations, the central bureau can predict the PGA and the alarm for any other place. And our system can still to detect the P wave signal and give a more accurate amplitude of the following shear waves. Okay, after the shake that I mentioned, we have to know the safety of the building. So here we just show a preliminary study. It's the Central Science Park in Taichung, Taiwan. It's a real building, and we put the model and put it onto the shaking table. So we can, based on the shaking table, we see the result and compare with the prediction result to know that our predict the safety or not is accurate, and we can believe the result. And also the sensors are put on the anchored building, our center. So after the earthquake, we can detect the flow response for some floors. And then we can calculate it's called the interstory drift. So we can calculate interstory drift. If the value exceeds the allowable value, we can give some alarm. However, we can, based on this earthquake, we say all the green means that all the building all the flows are safe enough. Or if the industrial drift exceeds the allowed value, this flow will become yellow or become red. Okay. Okay, so P-waiver can give the total platform. We can see that for the target building, we can put some information about the building. And then we know that the sensors are installed in what levels. And after the earthquake, we can give an earthquake report because the one on the ground can be used as the on-site warning system. So, and we can take the data, we can calculate the industrial drift, and know the safe or not. And finally, we have a stress monitoring report. Then next, P-waiver is still study on the AI system. We want to make the more accurate predict result. And the signal will pass to the partner company. For example, we have some company to automatically control the elevator to stop at the nearest floors, or we can to shut down the gas to keep safe. So, and also, the signal will pass to the high-tech industry, so they can shut down their process, and we can also to the high-speed rail, we can break in earlier. So the vision is that we have to building a smart building, and if the total building install the system, we can smart community, and they want to call it a smart city. Okay, that's all of my presentation. Thank you for your attention. Thank you.
Thank you very much. Very much. I don't know if anybody has any questions on that. Don't leave it all to me, but I can ask a question. Who owns all the data? That's the thing that I'm worried.
Who owns the data?
Yeah.
Because the data will be stored in the server, and the server, the P-waiver can keep the data, and for the customer buildings, so the building, the owner, don't be afraid that your information will be passed to the public.
Okay.
Yeah.
Lovely. Thank you very much indeed, Juin-Fu Chai.
Okay. Thank you.
Thank you.
Thank you.
Great to have you.
Thank you. Oh, it's really bright. Okay. Hi, everyone. It's my honor to be here and share my insights about two technology direct contribution to mobility, EVs, and green energies. So actually, the earlier introduction is different company. So today I would like to, focus in the power modules and the mobility area. So these are two technology I would like to talk about and share my insights. So Sentec Group, I'm a spin out from Sentec Group. So Sentec Group has been in automotive business since 1968. We have about 1,500 people in the world. We do a lot of manufacturing in Asia. And now I'm a spin out to talk about to build up the local factories in every country, because the decentralization, making locally is the future. So we are here to become a startup and to invite a lot of local partners to join with us for the manufacturing, for the green energy and the EV sectors. So I'm responsible for the power module side and the motor side, and later I'll talk about this, sorry. And we have, we provide solution to these tier 1 customers, a lot of automotives, and a lot of automotives customer, they own the battery, and eventually the battery goes to energy storage system and direct contribution to green energies from solar panel and wind turbines into this ecosystem for the automotive guys. For example, Honda from Japan, they own the battery. They do a lot of energy storage system. So now today, the energy crisis is actually much higher attention rather than the EV booming age. So energy crisis is one of the problem right now. So these two technologies are the main contribution. So sentec, we are in these two sectors. If you see the tiers of the ecosystem, automotive ecosystem. So in Taiwan, we have a rich semiconductors. So we use we call the power device. The power chip goes to inverter converter modules and goes to the mechatronic of the motors. And sentec is in these two layers, tier 1 and tier 2. So we also provide the micro mobility areas for metropolitan stuff like shipping, fleets, Ubers. All those need to convert to EVs, not the gasoline vehicles. And also we buy the chips from big players and make the inverter and inverter on the heatsink, for example like Tesla. So these are two technologies we offer, and we try to manufacture it locally in every country because the deglobalization, decentralization. So we spin out as a startup to welcome people to join us. And, we try to root down with every local partners. So this is the current status. It's a busy chart, but focus in the red side. First of all, we want to implement the power module manufacturing because that's the biggest shortage, because the CHIP Act. There's a TSMC everywhere in Germany, in USA, but after the chip is packaged, after the chip is manufactured, there's no packaging in the local demand. So the packaging is very important sector. So we try to go to every countries to set up this we call a micro factory line. We start with micro factory, and it's like a small flame to shoot for higher mass production. So we would like to work with the local partners. And something about power module. Power module is the heart of the EV. The DC to AC, AC to DC inversion, and also DC-DC in many fields. So let's take an example. So in the current technology today, there is an IGBT system. So Taiwan, we have this compound semiconductor and SiC. We can reduce the size of the system. Not just the size of the system, it's a smaller and higher power density. Actually, you save more money in the annual cost of the gasoline electricity price. So you save about, now this is like the chart 5 years ago, the price actually went up, maybe it's like $3,000 saving per year for any households. So that was on the Tesla bench information. So this technology, it's been widely adopted on the Tesla 6 years ago. And Chinese, the BYD also adopt this technology, SiC module. And Lucy Air from USA, they are a startup, and they have won the award of Car of the Year award because they create a very small power density mechatronics. So once this is the chip, is fabricated, 90% of the people do the discrete package and on their power electronic applications. So power module is very important. You put many pieces, many chips in the module side, mainly to improve the 10x reliability. So by doing so, you can run at a higher temperature to reduce the carbon footprint and the CO2 emission by having a high reliability interconnection technology. So the inverter converter is everywhere. I'll just explain from the EV sector. And actually, every country has green energy projects. So we believe every country should make their own power module locally. So from the solar panel and the wind turbines and energy storage system, all these are the good areas for localization for parts. And this is my main purpose to come to UK and trying to find a partners locally to build all this inverter converter. So you don't have to buy from anybody else. You just get the chips. You buy the chips maybe from other folks, and you can build it locally for your green energy projects. And for the EV market, there's a huge market for this business because the ICE market is going down. And this chart, I want to talk about the micro-mobility. I think because the inflation is happening, and the price is much higher for the current EV, and there's not enough electricity to charge. Actually, in Europe, in Switzerland, in Swiss, last year, because the energy shortage, the EV couldn't go on highway because not enough energy. And the server couldn't turn on the air condition due to the energy shortage, but the server still need to run. So the overall temperature goes high. So this is a huge market. So it's not about competing in the world. It's about making more lines to this booming market. It's everywhere. So it's millions of parts need to be made. So not just chip shortage, the module shortage, the packaging material shortage, and also making locally a challenge. So this is some open tool package. Our business model is a subcontracting manufacturer. So this is an open design to reduce the cost for the customer, the NIE cost for the customers. And our technology is why our packaging so important? Because we could reduce the chip usage. The chip is very expensive, so we can reduce like 6 chips per module. This is a direct benchmark with current industry leaders. We could save 6 chips. 1 chip is like $10, and we can really save $60 on the power module side. This is a full SiC. And this is a mechatronic version. In the same chips, if the chip quantity is the same, we can boost the power density to 30% more with the same chip. So we are very good at thermal conductivity designs. So once the design of the module is completed, we can boost the energy of this motor. And not only we can reduce the chip or increase the power density, we also have high reliability straight inductance design. And this is also to increase the reliability of the battery and the controller side. And lastly, I want to wrap up because the time is up. So the mechatronic, we also make motors for the micromobilities. So this is a big sector. It's not as competitive in the regulation, but it's more competitive in cost. So this is what's going on in the world. A lot of scooter makers, they mix the micromobility with the motorcycle powertrain. And gradually, they can even make micro EVs. I think you might see some micro EVs running in Europe. And also, I think it's going to be a popular option because the inflation and also energy crisis. So the micro-mobility could be a direct contribution for fleet markets, Ubers, or corporate ESGs. A lot of company has cars that they need to switch to EV. So maybe that's one way for mobility, the short distance, like 200 kilometers. So this is one of the vision, as a Taiwanese, we're trying to promote from the chip side all the way to mobility. And the best part is everybody can label their brand. We're just trying to sell the powertrain. So every country has an EV startups. So they can just take this and then make their own brand. Okay, so I'll skip all this technical stuff. And we have a testing center and Dyno Lab doing all this testing. So thank you. So that's all. Thank you. I hope my timing is okay. Oh yeah.
Stay around. Don't go. Don't go. Do you want to take? Are there any questions for Jason? Yes. I'm going to rush over to you. First of all, tell us your name, where you're calling in from. Where you're calling in from? Sorry, I've been doing too much telling.
My name is John, and I'm just an attorney. I just want to know, when you go around the world and you set up shop in another country, what's your biggest obstacles? Do you find the skilled people you need? Or do you need more help from the government, not just in terms of financing, but just in making it easier for you to set up shop? And do you have any comments on the UK or Canada?
Thanks, John.
Yeah. So for example, we are manufacturing worldwide. So we are very comfortable to go to every country, and usually we start with the universities, and we ask for incubation center space. We want to transfer the talents from the university side to become management or designers and high-end engineer, and then we also go to community college to look for the blue-collar talents. They are more hand-on the machines for manufacturing. So that's it. I mean, that's how we started. And because this is a big shortage in packaging, in assembly, so we are doing okay with the partners we build up locally. So we start with the university or institutes in every countries. Yeah.
And your presence here in the UK, is that what?
Yeah, so I just had some dialogue with some professors. So we were trying to find, I think there's someone trying to send me out with a university. So that's where we at, yeah. I haven't come back.
For the follow-up question.
Yeah.
So you think you will find the skilled labor you need in this country, and what would you need from a government department or here?
Oh, incentives, because very heavy, making locally will create a lot of cost ups. So I think the government should have some regulation. If you ship outside, you have to pay higher with the taxes higher. So if you have this kind of regulation in the nation, it's more likely to succeed this micro factory scheme. Yeah, or the mega factory scheme. Yeah. Thank you.
Thank you very much, Sean. Thank you very much, Jason, everybody.
Thank you.
Thank you.
Thank you.